Right. Good morning, Ann Elise Record. I'm so excited for this conversation. Thank you so much for coming to be a guest on Blue Glasses Math.
Good morning. I'm so thrilled to be here with you. So
Well,
excited.
so great. So I have to tell listeners that before I hit record, we were just jamming about everything. And I literally wrote a full page of notes with like diagrams and arrows. If you're watching on YouTube, you can see my scribble, my chicken scratch. And I'm like, we just got to hit record. We just got to go because this energy that you bring to this conversation is so, so rich. Um, so thank you. Thank you
Of
for
course.
everything you've done so far in math education. And I can't wait to put this episode out to the world so that people can hear more of your brilliance. So
Oh,
thank
it's an
you.
honor to be here. Thrilled to
So
be here.
fun. So fun. We're going to have a great conversation. So, Annalise, let's start with your math story. I ask every guest that comes onto this podcast, or every guest who comes on for the first time, because I'm starting to think about I need second rounds with people. I'm not going to
Mm,
repeat that. I'm not going to have them repeat their math story unless something has changed.
hmm
But I'm always curious about people's math stories, and the way I frame it is not just your math story of like the things that happened to you, but like what were the moments, who were the people, maybe along the way who influenced something about how you see yourself in the world of math, and how does that connect to what you do in work right now?
Yeah, I love that. I love starting with math stories. In fact, I ask everyone that I meet their math stories as well, because I think it's so telling about someone's experience, whether they think they're a math person or not a math person. So I can share with them that we are all. There's no such thing as having a math brain or not a math brain.
Totally.
And unfortunately, I hear the vast majority of people tell me very negative stories, very strong emotions attached to them as well, like frustration and anxiety, stress, but also words like despair, tears. Like that's such a shame to me that people would have experienced math in that way when it can be such a joyful experience. And it is all around us. We use math all the time, right? So for me personally, when I grew up learning math, I was a memorizing champ. I could follow rules and procedures. So I was designated as the high flyer, getting the attention for being strong at math. And so I, all the way through school, like I was able to mimic back to my teachers the procedures and things that they were showing me how to do. And so I felt like I was a math person, right? And I thought I might even major in it in college. But then I discovered sociology. And I'm
Ooh.
like, what is this world? And so I majored in sociology instead. But then I went back to school and got my master's degree in order to get certified to teach. And I had one class with math, and it was math and literature. And I love using picture books to explore math. But I came out certified kindergarten through eighth grade in New Hampshire. No more understanding how a kindergartner learns math than an eighth grader learns math, but I could be their teacher of record. I could walk into any of those classrooms and be their teacher, right? And so it was, I taught grade five for 13 years. And for the majority of those years, the only way I knew was the algorithms and procedures because that's how I learned it. And no one had given me training on how skills. And I was looking at I love math, my favorite part of the day. I taught all subjects, but math was my favorite part of the day. And I know I wanted students to understand the mathematics that I was teaching. That was very important to me. So I was trying to do like manipulatives and things, but it was really only using manipulatives to do the procedures.
Oh my gosh.
There's no flexible strategies to it. It was the end, I thought, was to get everyone to do the algorithm and how can I help them understand why it's working? Well, I can use base 10 blocks and things like that, right? So then I went to, well, my district created a position of math coach. And I'd been working with the paraprofessionals for a year because they were, we were a Title I school, which meant we had a lot of Title I money that allowed us to have professional, educational assistants, our paraprofessionals. And so we were beginning to have them work with math. So the majority of my classroom experience, the Title I assistants worked only with literacy. They didn't help with math at all. And so we were making a shift to have them help with math too, but they were like, we don't understand this math that you're doing now. What is going on? And so I met with them for half an hour a week over the course of a year. And then by the end of the year, my district chose to create a math position. And so I became math coach, K5. And that's where my world opened up because I could focus just on the math. But I also could, you get an appreciation. My biggest takeaway from leaving the classroom and focusing on the elementary math and getting training from people was that it's a connected math journey. It's not separate, isolated skills at each grade. It's a connected math journey. And one of my most significant moments in math for myself, most impactful moments, was I was taking a 1 week training in the summer with a gentleman called Dr. Mahesh Sharma. And it was an intensive experience, which is awesome. Kids came in even. We got to practice what we were learning with children. It was,
So
yeah,
good.
it was magical. But we had been doing, he introduced me to Cuisinart rods. Now, I had used Cuisinart rods as a child. I went to school at Henry Barnard, which is the elementary school on the campus of Rhode Island College. My dad was a professor of math there. And so
Ah,
I went there. So I remember being guinea pigs. Like we were in rooms with two-sided mirrors so that I knew college students were watching us learn. Like we were the guinea pigs of the future college students. And so I know I had Cuisinart rods in my hand, and I'm 57. So they've been around for a long time.
yes. Yes, they
But
have.
he reintroduced me to Cuisinart rods and the power that they have to move our students from counting phase of reasoning into additives. So they're using chunks of numbers, and then into multiplicative reasoning, where we're doing groups of groups, and then into proportional reasoning. So we've been building the area model with Cuisinart rods of multiplication math facts. And we've been doing that and focusing in on that. Well, then he took it to the next level of like multi-digit numbers for that area model. So we have in the ones place using Cuisinart rods, not all the base 10 ones cubes, because often if the manipulatives we have are that 1-to-1, kids will count. So rather than building a 6x5 array within that area model of 30 cubes, you have instead your choice of 5-6 rods or 6-5 rods, right? You're seeing it exist as groups. And so just that was like, oh, this is amazing. Like what a amazing way for the manipulative to help us move forward. But then he got us to doing division with the same model, the same area model. But then at one point he said, okay, I'm going to give you a polynomial. I won't forget it. X squared plus
I'm freaking out.
5x plus 4.
I'm freaking out.
And I want you to divide it by x plus 1. And my brain said, I'm out. Like, I haven't done that since high school. It's been decades since I did that. And then he said, but I want you to use the same thinking we did for the basic facts. I want you to grab the rods that match that polynomial. So now the length of the 10 rod was an x. And I want you to grab that pile. And then within 20 seconds, I had built the area model using the division, coming down x plus 1. I mean, I was like, oh, wait, the power, like this connected math journey. I can work with students in grade 3 on area models with basic facts for multiplication and division, but that sets them up for success to then do the same thing with mixed numbers, decimals, integers, polynomials in high school. Like, how did I not get ever experience with this in my own journey of learning math?
I
Right?
literally am going to go take my Cuisinart rods out after this. In fact, I think they're in a box underneath my desk. I am not even kidding you. I'm going to go bust them out. My son's going to be like, what are you doing? Like, it's raining out. I can't do anything. I'm going to play with my Cuisinart rods.
They
My
are the most
God.
powerful and versatile manipulative that we have. And the
That's
key for
incredible.
me is it helps move the students from different phases of reasoning. So I love how Pam Harris has developed the development mathematical reasoning. She's out written books on it now too, which is fabulous. But that image that I had of the K-12 journey of counting into additive, into multiplicative, into the proportional, and then into functional, like so that's where we are living. And I'm an elementary consultant, so I'm working primarily K-5 all the time. But to help teachers understand the mathematics, that yes, we can have a fifth grader who's counting 1 by 1, right? And we can have a kindergartner who's using multiplicative reasoning. It's about where they are in their journey, not what grade level they're in or what standard they need to be. It's where are they on their journey and how can I facilitate that journey moving forward for them to provide access for every single student to have a rich mathematical journey that builds their identity and their agency, that they understand their brains can learn, right? That whole climate we want to set in our classroom that's welcoming, that every student can feel welcome and safe and take risks and know that part of the journey is to make some mistakes along the way, but also the benefit of us learning from each other, that your thinking is different than mine. So if you share with me how you did it, then I share with you how I did it. And then I, as a teacher, can be facilitating in a classroom of students the same thinking, but maybe use different models, right? So maybe you did the same thinking, and I did this same thinking, but you built it with Cuisinart rods, and I wrote it with the abstract equation. It's the same thinking. It's not that yours is less than mine because you did it in a concrete way. So if I could rule the world, I would have a baggie of manipulatives, which include Cuisinart rods, within the arm's reach of every student
Yes.
at all grade levels
Yes.
at all times.
Ann Elise Record for president. I declare. Let's do it.
Right? Because it's a choice. It's a choice to engage visually in a task. It is not meaning that I am less than someone else if I choose to engage in it visually. Now, when I grew up, I learned abstract ways, equations and formulas. I did it easily. So I thought I had that math brain, right? But we want all of our students to understand that they can solve math. I'm so sorry. I'm 57. I'm losing my thinking.
No, you did so. That was amazing. I'll cut that out. I will cut this part out.
Menopause is killing.
So, me too. So you're trying to say that, and I'm going to do the same thing, that the manipulatives, you were talking about the manipulatives and how connecting.
Okay. No, I get it now.
Go.
Okay. All right. So when I grew up learning math, it was very algorithmic formulas and procedures, but I could do it really well. That wasn't a problem for my brain at all. I could easily memorize and mimic back to the teachers what I wanted to do. When I was in grad school and learning about like multiple intelligences, which has been debunked, by the way, but I was like, oh, we all have different ways of thinking. So I have the musical brain and the math brain. I don't have the visual brain. I didn't think I could do that until I had a consultant come to our school, Tom Schurston, who taught everything visually, K-12. And I had never used pattern blocks for fractions before. I had never seen an area model at that point. Like these are things that the visual ways of engaging in the math I had never had experience with before. And it built the visual part of my brain. By the fact that our brains are neuroplastic and that they can grow and change, I have built the visual part of my brain. So I now choose to engage visually in any task, right? It's my choice. It's not that I'm better at math than anyone else. It's about the experience. And that's what I find a lot in my work with, in my consulting work around the country with teachers is that I expose them to these strategies, flexible ways of thinking with numbers that are built on relationships, on the properties of the operations, things that when I read those standards, I didn't know what they meant. Right? We were talking about use properties of operations. I thought like multiplication, oh, it's commutative property. I can change the order of the factors and get the same answer. Or distributive property. I can break it apart by place value to get them toward the algorithm with understanding. But I've never seen double and halving before. A life-changing strategy that I could change the numbers I'm working with to make them more efficient for my brain and get the answer that you want in a much more flexible and efficient way. One of my other favorite moments in my story as being an educator of math was I do a lot of work with math running records. I know you had Dr. Nicki Newton on recently, and she's my mentor. She's just the most amazing person, the most research-informed person I have ever met. And she's just generous and kind, and she's just everything you want in a human. So she is my mentor. And so I had gone to a training of hers, and it was a literacy and math conference, BER, Bureau of Education and Research.
Oh, yeah. Mm-hmm.
I was putting it on, and you can choose who you wanted to see, what sessions to go to. And I went to her first session that was math, because math was always my favorite. I love teaching all subjects, and I love reading stories to students and all, but the math was my favorite. But she was showing me things like an open number line, and it was, the core standards, right, had come out with what these meanings were. And so she was letting me know like what this math world was. It was, again, my math opening up again. Now I had visual ways of doing things, but now I have flexible ways of getting answers. So I didn't leave her side for 2 days. And we ended up hiring her to come and consult with our district, and she doesn't like to drive. So she was like, oh, I'll just get a driver or a taxi. I'm like, we're in a northern New Hampshire, tiny little mill town. Taxis don't exist. So I'll drive you around. And that began our many, many years now of friendship and collaboration. And so I drove her the whole week, and we just became fast friends. We're together day and night the whole week. But she's
an easy one to become fast friends with, for sure.
Yes. Oh my gosh, absolutely. And about that time, she was about to come out to publish her book, Math Running Records. And I now was becoming a math coach, and I was learning all this mathematics with Dr. Sharma, and that I wanted to share with my colleagues as the coach now to kind of make sure all of us understand how much expertise there is in elementary math. I mean, just the word birth to kinder is its own world of expertise. It's its own world of understanding, right? And I had zero appreciation of that when I began teaching. But she came out with her Math Running Records, and I went to a webinar she was sharing on the math running records. And in fact, I'm quoted in the back of the book because I began doing them in my school in the first year that I was a math coach. Because number one, it was helping me educate teachers on the expertise of early numeracy it's not about kids knowing their facts and not knowing their facts. What facts do they know? And how can I help them connect the facts they do know to the ones that they need to learn? And where is their thinking, their phases of reasoning, right? Are they counting every single amount in both numbers? Or are they counting on one number from the other? Is it the larger number they're counting on with? Because I want to make sure that I'm most efficient, but that's all counting. And a lot of my fifth graders were stuck in the world of counting. I did nothing to help them move forward. I didn't know about like additive reasoning, how I can use doubles to help me find something nearby, or I could bridge a 10. The associative property of addition of I can take a chunk from one number and reassociate it to the other, right? To change the number that I'm working with. So 8 plus 5 can become 10 plus 3. The 2 that I need the 8 to become a 10 with is existing in that 5. So I can decompose it and reassociate it. Well, then that works for 98 plus 57. The 2 I need to make 98 be a 100, I can get from the 57. I can break it apart, reassociate it. I'm not stacking them and starting in the ones place and then counting the basic facts and having to regroup and having a hot mess of that, right? But it also works for 4/5 plus 3/5.
Right.
The 1/5 I need to make 4/5 a whole exists in the 3/5. I can decompose it and reassociate it. So when our standards say using, any of the operations with based on the properties of operations, that's what it means, right? So anyway, the story I wanted to share with you was this math running record multiplication in a fifth grader. And the teacher told me he is the lowest of the low. I no longer use terms like low and high for a student. I don't use things like red, yellow, green, blue, even though I did for many, many years. But I live by Dr. Maya Angelou's quote that we do the best we can until you know more.
I agree.
And when you know more, you do better.
Yep.
So, and this is the moment why. This is what showed me why. Because I had this preconceived notion of him coming in, and I was modeling the running record for teachers. They could see how we administer it. And so the teacher had said before he came in, he's the lowest of the low. And I said, okay. So when he sat down, I had asked him, the foundational facts come first and the progression Dr. Nicki created from all the research. So 2s, 5s, and 10s, because we can derive other facts using those, right? So the 5s are early on in the interview. It's a one-to-one interview with students. It's free. It is just, yeah. And so our
people can watch this, or so you said it's free. It's
the math running record protocol is a free
the protocol. Yeah. Okay.
Yep. So anyway, so I asked him 9 times 5. And the first facts I had asked him, he was prolonged thinking with them. And in part 1, we're just trying to get a sense of the relative speed and accuracy. So he asked them one expression in each strategy zone. Well, anyway, he had been taking a long time with those. In part 2, we do the deeper dive. It's the heart of the interview of asking them more expressions. When I asked him 9 times 5, he thought for a while and he finally said 45. And I said, super. So what was your thinking? How did you figure it out? He's like, well, I halved that 9 to 4.5 and that times 10 is 45.
I halved the 9 to 4.5.
And that times 10 is 45. Now, the vast majority of students that I meet in 4th grade tell me how they're adding a 0 when they multiply by a 10.
100%.
This young man was having an odd number to a decimal and then shifting the place value position times 10. The thinking and reasoning was objectively the most elegant thinking I've heard from a student, sophisticated thinking and reasoning.
100%.
Right? And I was in the classroom at that time being a math coach and sharing with students double and halving as a strategy. But I was telling them you can only use it for even numbers.
Isn't that so funny?
This young man whose teacher thought he was the lowest of the low, he'd been in her classroom for months, right? She thought he did not have any mathematical thinking because she wasn't talking to him. Right?
And she wasn't listening.
It's no fault.
No.
The teachers are doing an unbelievable job.
100%.
There's so much stress, particularly after COVID and all this stress and testing, all that. So I'm not faulting anyone, but we need to make sure that our classrooms are full of the math practices. We have students critiquing the reasoning of others. They're constructing their own arguments. They're problem solving and persevering. They're using models. They're having physical manipulatives that they can make their thinking visible, right? I don't say to students, I need you to show me your work. say, I need you to make your thinking visible to me.
Yes.
I'm interested not just in the answer that you get, but also the thinking you did to get there. And that's how I want to share it with others. So I love Peter Liljedahl's work, the Building Thinking Classrooms, right? So when I think about what have thoroughly influenced me in my math story, Dr. Nicki, huge impact on me, changed my life. And the other woman that did was Christina Tondebold. So
Yes.
Christina had just begun having her Build Math Minds website, and she created a class on the primary grade level of learning math. So that's when I learned about subitizing and the importance of decomposing numbers and like all of the elements of number sense that we need to focus on, provide that foundation for all sets of numbers for our students. And I joined her community, Build Math Minds, early on with it. And then I kind of became known to her during my comments and things. And so she ended up having me give testimonials. And eventually, when my husband got a new job, we were moving 2 hours away and I didn't know what to do. I was expensive as a teacher and there weren't any math coaching jobs down in the southern part of the state. I was going to a much more populated area of the state. I wasn't in the North Country anymore. And that's when Christina and Nicki both changed my life, because Christina said, well, could you, I'll give you a monthly salary if you could build me some videos for my Build Math Mind site. And then Nicki said, I can give you my connection and manager at BER, Bureau of Education and Research. So I began doing seminars, I still do, for the Bureau of Education and Research. And back then we went in person, traveling the country. So I would be in, for 5 days in a row, you go to one state, the next day you could be in a different state, and then the next day on the Wednesday, all the way through to Friday. And so you pack up your bag every day, going to a new conference hotel room. But when people would see me, they would go back to their school and say, we need to have her come to our school. But then they would hire me privately to do the work there. And then word spread. So I've been all over New Jersey.
Amazing.
Because the principals talk to each other, and then I will go work at a different school. And so my first beginnings in consulting was traveling around the country, because that's where my connections were with BER. And so I would would do videos for Christina, but I also began my consulting work, which then flourished from there. And so the two of them, Christina and Nicki, literally changed my life. But then also Peter's work, right? Really influenced me, because I'm like, oh, everything he said resonated with me so deeply in my soul. We want a human side of mathematics. We want everyone to understand from the random groupings, which send a message that I believe every one of you has something important to contribute, right?
Yes.
And that we think of them as Swiss pieces of Swiss cheese. Peter says, like, you put 3 of them across each other, the holes get filled.
It becomes Velveeta.
It's not me showing people this is how you do math. Like, that's what I thought my job was to show the students how to calculate 2-digit by 2-digit using the algorithm, dropping a 0 with a smiley face. Now, and I wanted them to understand, I talked about the place value. Of course. There was no turtles dropping eggs in my multiplication.
Okay, that's good. No turtles were harmed.
No turtles. There were no butterflies happening in my classroom. No alligators either. No place for any of them. And I heard Dr. Nicki mention that in the podcast with you. It's so true. It's so true. It's well-meaning. But I want the understanding to happen, right?
Yeah.
And so the work of Peter's work with Building Thinking Classrooms, we want every student thinking and reasoning. We don't want them to feel like they're alone, right? They're together working in a random group, and those groups change every day. I also love Ken Williams. I love how he shared a story once that when he works in districts, he begins by saying, like, so I've asked the principal, and I'd like you to sort yourselves by the low, medium, and high teachers.
That is fantastic, right?
So I'll say that in my trainings. Like, I didn't get a chance to ask the principal who's high, medium, or low teachers. So I'm going to do it randomly. So here are my Uno cards to sort you. And they get a little chuckle, but like, I mean it. Like, that's our students know. I did that myself. So I implore people not to do the things I did do when I was a classroom teacher. I gave time tests 2 times a week. I had to give a score and a report card for them, right? Yeah. But I was sitting in a number one. I was sitting in a conference session by Marilyn Burns, and she said, "Time tests had a birth; they can have a death."
Oh, that's beautiful.
That
is a beautiful.
And then I was in a training with John San Giovanni, and he said, "You can't fatten a pig by weighing it. We can't build fluency by just assessing it." And I'm like, true. Oh my gosh, that's what I had been doing. I had been assessing fact fluency and doing nothing to help any of my students do better the next time. Nothing was happening between my administration of those tests that would help any of my students think more multiplicatively or in subtraction, build flexibility on that. Like nothing, I did nothing. I was just affirming to my students twice a week, you are a math student, you are not a math student. It was scored outstanding, satisfactory, needing improvement. So my outstanding kids who stayed outstanding all year long got the affirmation as I read off the answers to everyone, corrected their own time test. And I was affirming to my students who were needing improvement, who all stayed needing improvement year long. Like, why would they be intrinsically motivated to, like, as if it was their fault that they didn't know their facts, or their family's fault, or the third grade teacher's fault? Like, that's what is supposed to be happening in third grade. What are those teachers not doing that by time with me in fifth grade? Do you know my content? I don't have time to deal with basic facts. But I didn't know the power of beginning the flexible thinking and making it visual and practicing it and then extending it to the other sets of numbers. It's not an isolated skill. It's the same thinking of reasoning. I can double in half with a basic fact, and I can double in half with 1.5 times 18.
Yes.
It literally becomes 3 times 9.
Yes.
Like, how is that not a choice for our students? If they don't own these strategies, then they can't choose them. So I love Jenny Bay Williams and John St. Giovanni's book, Figuring Out Fluency.
Yes,
it is a K-8 book because it's a K-8 journey. All sets of numbers are applying with it, right? And so I love a routine that they shared of giving the students the element to practice the choosing, right? Without the cognitive load of having to calculate answers. So you just create a bunch of expressions and say, which of these might you choose double and halving for? When you know you could do it for all of them, like the young man who did 9 times 5. He chose that as his pathway. He literally renamed the expression to different numbers. And that's also in our power for any of the 4 operations. There are some strategies when I'm working with the numbers, and I can model them to make them visible, right? The models are how I make the thing visible. The strategies are the thinking and the math that we're doing. So I'll have teachers telling me, I've worked on the strategy of open number line for a few weeks now. And my response is always, well, what is the thinking that you're showing on the number line? Because I can show you counting 1 by 1 for 9 times 5. But I also can show you thinking 5 times 10 is 50, so I can remove a 5 to get the 45, right? Like the thinking is very, very different, even though the model is the same. The open number line is the same. So that having these bunch of expressions, and what would you choose to do it for? You can do it for any. So what's your brain telling you? So we're giving them that practice of the choosing. I love, I heard Amy Lucenta say once, we want students to contemplate before they calculate.
Yes, I've heard that before.
Right? So when you're given something to think of, any kind of expression, looking at the numbers first and have it speak to you. Like, is there anything, before I jump to that algorithm, because too often the students go right to the algorithm. My favorite operation right now to talk about is subtraction. I think it's the Achilles heel of all of
people
our
hate subtraction.
Presenting on it at the national conferences and all the state conferences that I do, because I think we can fix this problem when we ourselves build our understanding of subtraction.
Yes.
Right? There's 2 meanings of subtraction. If I ask someone to do 90 minus 12, typically mental math, we would take away 10 and take away 2, right?
Yeah, sure.
If I ask 92 minus 88,
yes,
our brain kind of naturally goes, well, I can add up to find the distance. I can do 88 to 2 is 90, 2 more is 92. Our brains will do different things depending on the numbers we're asked to calculate with. So when I have teachers tell me, well, I tell my students, like I share them one strategy on Monday, another one on Tuesday, another one on Wednesday, and say, okay, it's your choice, kids.
Can we talk about that for a second?
Yes. Practice it and own it.
Own it. I think that's,
So students will just use addition to solve subtraction. I
think that's a common theme in this whole conversation.
Yeah. I don't want them doing that for, 426 minus 13.
Right.
Like, you could, but why would I? I'd rather take away 10, take away 3, right? So it's about owning these strategies so that the kids can choose it, right? Ultimately building that agency that they have choice. And if we're not opening up our classroom to have flexible ways that students can do that, right? And flexible ways of making the thinking represented, like the 5 less translation model, like concrete and pictorial and symbolic and verbal and contextual, like those 5 ways. And I, as a teacher, can consolidate that learning, like in a building thinking classrooms, the kids are standing up at these boards and I can look around at the work that they just did. And this is what I do with teachers. I have them solve, my favorite expression is 52 minus 38. So I have a t-shirt also. You'll notice my t-shirt, I have phrases
No,
on it that are
I
funny
love
to
your
the kids.
t-shirts. You say the t-shirt says, for those people who are listening to this, not watching, it says, "You do not need to be fast to be good at math." And you wear t-shirts
Mhm.
all the time. I've seen you on
I do.
social
I
media
go on
constantly.
Etsy and have them
Yes,
made for me.
that's
Special
amazing.
phrases and things that I want to
Yes,
show people. I want to pass the messages to educators, but
love
also to
it.
the kids. So when I'm in classrooms, I want them seeing the message. I always tell as often as I can, any of the grade level kids that I work with in a classroom, you don't need to be fast to be good at math. You don't. It's your thinking. That's what I'm most curious about. 'Cause I can help facilitate your thinking, become more flexible and efficient, right? And that's the element that I find too, like with time tests, they're just measuring speed and accuracy, but that's not the definition of fluency,
No,
right?
exactly.
So the definition of fluency isn't speed and accuracy; it's flexibility and efficiency and accuracy, and the flexibility of having a variety of strategies I can choose from, and then the efficiency of choosing ones that make the most sense for the numbers that you give me. Like if I am asked 1 5/10 times the 18, but I can choose that to be 3 times 9 to get the 18, like I'm much faster than I would be if I were lining up an algorithm, this times this, dropping a zero, and then remembering a decimal point to put in, and it swoops in and I plunk it in there. But
that
decimal points
that
never
magic swoop.
move.
That magic swoop.
But
I'm like,
decimal points never move.
I
It's
know.
the digits that are shifting place value position,
I know.
right?
I
So when
used
we're saying
yes,
adding a zero, well, that expires in fifth grade when we're doing decimal multiplication because you can
yeah.
add a zero at the end, but the value doesn't change. So being mindful of these rules that expire, so we're not seeing things, not saying things that expire down the road. And similarly with subtraction of like, you can't take a larger from a smaller. I was in a classroom when the first grade teacher was saying, you can't take a larger from a smaller. And then she put on the board 12 minus 13 and said, see, you can't do that. And I was an early math coach at the time. And I thought, I've only taught fifth grade. What are these primary teachers going to think of me coming in to give them suggestions, right? Should I say something or not? I mean, they're just first graders. Well, this one little 6-year-old raised his hand and said, actually, you can do that. That's -1.
Oh, beautiful. So let's go there for a second. So first of all, I just want to synthesize you. It sounds like your math story, it is this multifaceted journey, and you've used the word journey multiple times. And it's been influenced by the experiences you have put yourself in the room. Because I keep hearing you say, well, it was this person or that person.
Mm-hmm.
And yes, all those people, right?
Mm-hmm.
Because the same thing with me. Like I feel like I stand on the shoulders of giants, right? Like
Yes, I say that too.
I could not be here right now
Yes.
having this podcast if I didn't learn from all of these amazing humans, who I like geek out over when I see them at conferences. I'm like, I need to have a selfie with Joe Bowler and Peter and all the people. But I also think there's this piece where we put ourselves in those spaces
Mm-hmm.
to have those interactions with and to be lifted up by those lifted up onto those shoulders, right?
Mm-hmm.
And here's why I bring this up now. Because you're talking about this teacher, you're in the first grade classroom, and you're watching this teacher say you cannot do 12 minus 13. It just doesn't, it's not possible. And then the student corrects, right?
Mm-hmm.
And I wonder, because I just had an experience this week where I was in a PD, and I was the second time I was coming back to this group of teachers since October. So we're recording this in April. And the one teacher, fifth grade teacher, says, he's like, he said, you're back for more. I don't think he used the word abuse, but he was like, clearly remembers that we had a conversation about fluency. I had 25 minutes with these teachers in October to talk about fluency.
Oh,
and
gosh.
they were angry. It was grades, I think it was grades 4 and 5 in this one particular group, right? And they're angry because kids they're not coming up with their facts and this, that, and the other thing. We had 25 minutes. Like it was not enough. It was their grade level time. And I said to him in that moment when he said, oh, you're back for more. I said, you know what? My job is not to teach teachers how to do math. I mean, that's part of it. But the other part of my job is to manage resistance.
Oh.
And he smiled and I smiled and I said, and I'm here for it. I said, let's talk about it. And you're bringing up the idea of like I think our problem was 3.5. So 3 and 5/10 as a decimal and saying it 3.5 so people can visualize that in their head. I think it was times 14. right? So 3 and 5/10 times 14. And same thing, we were able to double in half.
Mm-hmm.
Now, we did Building Thinking Classrooms model of this. We had them standing at their boards, and we had asked them to come up with 4 different ways to represent 3 and 5/10 times 14. And when I looked at his board, it was like 3 different ways to do the algorithm of putting the 14 on
Yes.
top of the 3.5 on the bottom and doing all the things. He had it broken up in partial products. He had,
Mm-hmm.
but never did he double and half it until we went around and consolidated.
Mm-hmm.
And then he was like, oh my gosh, right? The power in that.
Yes.
The
Yes.
power that a student could have to know that they don't have to rely on what a teacher says or does to mimic, like you said in the beginning of this conversation,
Mm-hmm.
but that I can actually give my students the power. And then he was like, okay, I understand what you mean by dealing with resistance.
Mm-hmm.
Because the only way he was going to see that, I mean, I could tell him all the research. I could tell him all the things.
Exactly.
I could say, Peter does it this way, and Christina does it that way, and this person and that person, blah, 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 blah.
Right.
And he's going to be like, yeah, okay, but you're not in my 5th grade classroom every single day where these kids are not.
Right.
So I just need to give them the quick and dirty because I've got a million standards.
Mm-hmm.
I've got testing coming, breathing down my neck. I've got the data collection, quarterly assessment coming through. And I'm just flooded, so I just need to get through it.
Mm-hmm.
Then when we talk, so my point that I'm trying to make is giving teachers that opportunity to listen to students, because that's come up as a theme multiple times in this conversation.
Absolutely. It's about the student thinking and having their thinking drive our instruction, not our turning the page, scope, and sequence.
Yes.
It's what is the thinking of the student. So rather than me showing them a strategy Monday and then another one Tuesday, I'm going to instead give them a task where they're at the board so I can see what do they come up with, and do this with the teachers as well, right? I want to see where is their flexibility with subtraction, addition, multiplication, division. And I'm going to then bring everyone over to the board as I've selected and sequenced a few of the solutions, right? So that the work of Smith and Stein of the 5 practices, right? So then I bring everyone over to one board and I say, okay, who did this solution right here? Not the whole board of work, but just this one solution here. And I say to them, you can't talk. I want everyone else staying with your groups to talk about, can you figure out what their thinking was? Did they make their thinking visible to us? Right? And so that's math practice 3 of critiquing the reasoning of others. So I'm giving them that practice of, I could look at the work of someone else and figure out what they did. Right? And then we can go to another board. These people can't talk. Everyone else, what thinking, but I have selected them so we can have that conversation. What was the same between these two and what was different? And usually I do find with multiplication, it's the area model done by partial products by place value. There typically isn't much more flexibility than that. And with subtraction, a lot of like the different ways, as you said, of showing regrouping, like pictures of base 10 blocks where I cross out and I draw all these dots and all of that. Usually there is someone that did like a constant difference. So 52 minus 38, to bring it back to that, like they changed it to 54 minus 40. It's 14 and I'm done.
Right.
Why would we not want to have that as a choice for our students where I can do it with any set of numbers you ask me to subtract? I have the agency when I understand and own a strategy to change the numbers I'm calculating with and get you the answer flexibly and efficiently. And I'm there and I can move on to the next one. I'm thinking and reasoning, right? And that's what the key is that we want our students to do, and be able to have that variety of ways of making that thinking visible. That if someone built it and someone drew it in over number line and someone did it with equations, it's all the same thinking. Let's respect the diversity of each of our thinking, different ways of thinking. But when our classrooms are not open to that, if it's you must do it in this one way, and if you can't, I'm going to pull you in a small group and I'm going to just talk lower,
louder.
Louder and slower. I loved Rob Beyer saying that.
Yes.
Like, oh, he took my line, because that's what I say too, because I love it. But it's so true. That's what I did in my classroom, right? So
yes.
I do implore people not to do the things I did do, which was like time tests is number 1. Number 2 is keyword posters for problem solving. That's not the research behind what we need to do for problem solving. But primarily what I want to do is I want to find out from the kids what is their thinking by asking them, right? So the fluency work. The math learning record allows us to, within 10 minutes, I can find out for a student which set of facts they do know, which ones are causing their brain to have a slowdown, maybe some inaccuracies or prolonged thinking. It means that probably they are counting one by one if it's adding or subtracting, or they're skip counting in multiplication and division. They're not in the phase of reasoning where I want them to be, of like a 9 times 5 being, well, 10 fives is 50, so 9 fives is 45. It's no fingers trick, right? It's no skip counting. It's going to be a strategy they can use for 99 times 5.
Yes.
Right? Or 9/10 times something. It will extend all the way through the journey. And so I can provide the foundation for that. So you can provide catered fluency work with the kids of what set of facts you have to work on. This is not in, by the way, on a public bulletin board. This is in a folder between you and me and your family.
Yes,
because
exactly.
I'm going to ask your family to play games with you at home. That's your homework for math. You're going to be working on games that help practice your thinking and flexibility and efficiency. Because I'm going to have a family math night where I'm going to share with the families why we're teaching math the way that we are. And when I share these kind of strategies with people, they always come up to me afterward and say, I get it now. No one had told me this was why you were doing it. So the frustration of them having to work on a worksheet page that's using strategies that they've never seen before, it
so creates frustration
that they had for math. I
oh my gosh.
Vanessa Beccaria's work in the math therapy. I think that, and also Lisa McConchie's work on the brain science, her book, Building a Positive Math Identity Using a Brain Science Approach.
Yep.
I love those.
She's coming next. Or actually, you're probably after her. So I probably people are listening to this already heard Liesel because she's coming.
Well, then that's perfect. So
it's perfect. I
absolutely love, I love her work. I love that brain science approach of what we need for conditions for students to be able to learn. And when students are dreading and thinking they're not a math person, I don't have a math brain, they will not achieve as much. Their brain is not in a state that is hopeful.
Yes.
Of knowing their brain can learn and grow and change. That's what our brains do. They're plastic. They are always seeking out to connect what we already know to what we want to learn. And our synapses are firing. I liken it to like a beach path. If you go down it once, the grass would regrow. If you go down it over and over again, it becomes a permanent pathway in your brain. When I first learned about double and halving, I didn't own it right away.
No.
I learned it. I'm like, oh my gosh, that's powerful. But I did a lot of Pam Harris's math strat chats.
Yep.
So every Wednesday, she puts in public, out in any social media forms, different kind of expressions, but we're not allowed to use the algorithms. So you have to share beneath it in the comments. So I lurked for a long time reading the comments. And I would try it on my own, but then I would read down below to see like what did someone else come up with, and someone inevitably would think of like double and halving, and it was changed to such an easier expression. I'm like, double and halving. That's right. Now, because I took the time to build my own math mind, as Christian Tondeville says, until we build our own math minds, we can't build and facilitate the math minds of our students, right?
That's
we
true.
have to do the work first, and the power of that work is to provide access to each and every student. So when the upper elementary teachers complain to me about the math facts, they don't know their math facts, I'm thinking that would be a thorn in the side if the only way I'm having them multiply is the algorithm, because you're relying on having to know all their facts to do that. But you don't have to know all your facts to multiply, right? If I know my 2s, 5s, and 10s, I can multiply anything.
Yes.
And figure out some foundational facts, 5 being half of 10. Try that with like decimal work, right? That you multiply by a 10 with a shifting place value, and then you half it, and I'm done. Like, the power of that work is what is so exciting to me. And to see teachers' eyes light up. I was in California recently doing a training for a day, and just the educators were just amazing, and they were open to this thinking. But like the principal stayed in the whole day, which I love it when administrators join in on the trainings. Like, they're part of, all stakeholders need to be there. It was one of the first schools that I found that had every stakeholder. There was a long-term sub that was there for the day. Special educators were there. Paraprofessionals were there. The principal was there. Like, we are a community and a team to build the math identity and agency of all of our students. We all need to be on the same page.
I think I want to switch pivot the conversation now to systems level conversation. Okay. Earlier, before we hit record, I had written down that the systems, something we talked about was the systems are built on a faulty definition of what it means to do math. And until we start shifting that system, those systems, whether it be a system within a grade level, a system within a school district, a county, a state, a nation, right? Until we start redefining what it actually means to be successful in math, nothing's going to, I mean, things will change in moments and places and classrooms, right? Like in my own experience, I would just shut my classroom door because everybody thought I was crazy.
Mm-hmm.
Like, too bad. I'm doing it anyway. And at the end of the year, they realized, oh, she's not crazy. What's going on in there, right? And then because I did all sorts of what they thought were like nutty things with my kids, like doubling and halving, right? And why don't you just teach them the algorithm? Let's move on. But the reason why I bring this up is because you're talking about something very important. It's you go to a PD, you're hired by a district, you walk in. If there's an admin there, amazing. But you're telling me that they had a long-term sub
Yes.
in the room.
Mm-hmm.
Like
And
that.
special educators, because that doesn't happen very frequently. They have
Fair.
like their own training.
Right.
I know in my district, it had been, well, special ed has their own set of money. So they get their own. So every professional day, they had their own training. The administrator of special ed for our district would plan their PD. But like, why? And so that happens a lot when I'm brought into schools is the special educators aren't included. So I do put in my contract, at all costs, could you please have special educators and paraprofessionals and all stakeholders there at the training, if at all possible, because it's not different, right?
No.
If I could have every person involved in education read one book about math, it would be Dr. Rachel Lambert's Rethinking Disability and Mathematics.
Absolutely beautiful.
So that's like when I think about my own math story, what's influenced me along the way, there have been so many people that have influenced me. But when I think of a major shift for me, of a deepening of my understanding of how we can provide access for all of our students in a tier 1 setting, it's her book, because it's in one book, all the best stuff that I've been sharing for years. I've been a consultant now for 8 years. So all the things that I share are in her book. So she mentions Peter's work of building thinking classrooms. She mentions the fact fluency being flexible and efficient strategies. And she's working with students who have multi things, like they're multi-language learner and they have ADHD, let's say. Like she's sharing with us, can we rethink the definition of disability?
Yes.
What if it's not that our students are disabled and there are things that we need to fix, like it's a bad thing? Let's think about the strengths they bring to the table and how can we capitalize 100%. On those strengths? Is it our classrooms disabling students? Not their disability getting in the way of them learning. We're not providing the way that their brain is learning, right? And then rethinking mathematics. What does it mean to be good at math?
Yes.
It's not the fact that you're fast and accurate and can crank out algorithms and get answers quickly. You're thinking and you're reasoning and opening up the classroom. So I love you talk about opening up the classroom and then supporting our students in ways that meet all the learners. And I love what she talks about. It's not like a checklist. No. It's not like, do I have manipulatives out? Do I have this? It's about responding in the moment to the thinking of our students. So to have a style of our classroom where we're having rotations of stations, we're doing a building thinking classroom some days where we're able to have the kids up and out in random groups. We're gathering the information of the student thinking. That can then drive our instruction. Yeah. But we can't have that richness of every single student belonging when we're sorting them by high and low, when we're having an advanced math class or an accelerated class, when we're having the gifted program, right? That's sending the message there are some students that are better than others. And that's not okay. That's not human. That's not treating our students as humans and building that positive math identity for each and every student, right? So that one book has in it like number strings, how important number strings / problem strings are, a series of expressions that I can facilitate with the students and help them use the over strategy to multiply. But I'm doing it in a way that provides access for all the kids. Another phenomenal story that I had was a third grade classroom in the middle of the year, and I'd asked if they worked on their times nines yet, and they hadn't. So I began by doing 10 times 4, asked them to talk in partners. What is it, right? They figured out it was 40, and then I did 9 times 4 next. And asked, how did you figure it out? And there were students working together. Some skip counted and whatnot. But one student said, well, we just did like 10 4s was 40. So I just took away 4 for the 9 times 4. So that's what I chose to model on the board in an open number line. I'm like, oh, that's interesting. Okay. Then the next one I did was a set. It's a helper clunker format I love Pam Harris's work of problem strings. So I did 10 times 6. And then we did 9 times 6. And I'm always nudging. I'm like, I wonder if what we did up here could help you do that. And there were some students who were reluctant to do it. They were just like, skip counting still. That's
skip counting is comfortable and safe.
That's fine. And then I did 10 times 9. And then 9 times 9. And then I did 15 times, I did 10 times 9 and then 9 times 9. And then 15 times 9. and 9 times 15. And the kids did not know how to do 10 times 15, so we counted by tens 15 times. But the most important thing for me was at the 9 times 4 at the beginning, there was a young man in front of me whose hoodie sweatshirt was over his head. He was in on himself. He wouldn't talk to his partner. He wouldn't look at me. Clearly this disposition of, I'm stupid at math. I can't do this. By the 9 times 15 at the end, he was jumping up and down with his hand raised to share with the class how he could figure it out, right? It's like Pam Harris's math is figure outable, right? I might not know it for you yet, but I can figure it out. That disposition of I can figure these things out. I can think. And I'm sorry to quote all these people, but I'm so affected by so many people. So Deborah Parrott Creighton, her calling kids mathers.
Yeah.
Right? I love that. Readers,
we're all mathers.
Writers write. Mathers, math.
Yeah.
Right? It doesn't have to sound like a highfalutin mathematician, right? We're mathers. We can figure things out, and you're not in this alone.
Totally.
We're in this together. We learn from each other. Like there's no such thing as cheating in a thinking classroom because we're learning from each other. We're a community. I might give you an idea and then you get going, but it's not like I'm cheating because I'm copying your way, right? All of that classroom environment is what we need to build the identity and the agency of all of our kids. And I think that Rachel provides that in her book of Rethinking Disability, her last chapters on how can we rewrite IEP goals? Because very often the IEP goals are handcuffing our teachers because it's listing a certain skill, isolated skill, but it's not the understanding of subtraction.
Don't even get me started on IEP goals.
So how can we rewrite those, and how can we rethink what math is and what disability is, and provide access for everyone? It doesn't hurt anyone to have a sentence stem on the board, but it helps our neurodiverse students, our multi-language learners, our students that have dyslexia, and our students. She mentions also that. For the students who have disabilities in our classrooms, many of them, the majority of them have dyslexia, right? Like a reading disability with language processing. And very often they have a weakness in memorizing facts that are disconnected from things, but they have strengths in repeated reasoning and visual spatial. So the more we introduce into our classrooms, like I didn't think I had a visual brain my entire life until I was many years old.
I know,
right?
right?
But I now know I've built it. I now choose to do things visually. So how powerful an impact we can have as teachers to be able to help students understand that they all can learn math, that everyone can, right? And also help heal that trauma with their families, having family math nights to show them why we're doing, and then they're our ally in it. Like,
because you're empowering them. Right. You're empowering them and giving them agency, parents, right? Because like you said, so often parents the homework comes home and it's like, you know what? I just want to get this done the quickest and easiest way so we can get to soccer practice or that I can get to my second job. So here's how I was learned, here is how I was taught how to do it. Just do it this way.
Exactly.
And then what that does is it creates confusion for the kids. It creates a rift between the school. But if you bring the parents in as partners, I love that, and helping empower them so that they understand why we are doing the things we are doing. A lot of times we don't understand why just by somebody saying, well, the research says.
Right.
And I don't know why I lowered my voice there, but I'm becoming a man all of a sudden. But like some authority says that we must teach math this way. And it's like, no, but here, try this.
Right.
Let's, how would you subtract 400 minus 95?
Right.
Are you going to regroup?
Right.
No, you're not.
Right.
You're going to count up, right? You're going to, and then when people, I don't care whether it's a parent, administrator, teacher, student experiences that, then there's space for the conversation. Right. And I think that's the part where it's really, key. But yes, so, oh my gosh, this conversation could go on all day.
I could talk to you all day. I just want
so
to share
fun.
one more quote that we
go.
link to that. Kathy Quinn says, experience changes beliefs.
Yes.
And I found that with the teachers that I work with, I need to give them experiences to double and have, and the choice of which would you choose these for, and then have that 1.5 times 18 there for my third grade teachers, right? So that they're like, oh my gosh, like then they're in, like what? Oh, this is something I've never known about. It's no one's fault, right? We weren't given the training in many of our teaching training programs to have that flexibility. But what I do love is that a lot of state standards now are listing the definition of fluency as flexibility and efficiency and accuracy. It's not just saying fluency It's left up to the reader to think, what does that fluency mean? Oh, it means speed and accuracy, right? They're being much more intentional of these best practices of things.
Yeah. Yeah, because anybody can be accurate by asking Siri.
Right, right. But can we give experiences to our students to
Right.
think and reason and be successful and be a community we're all learning, and so that they can feel safe to explore?
Yes.
Then their brain's in a state of hopefulness
Yes.
that allows them to engage in the learning, that they know that they can learn. It's not just a hard and fast, I don't have that brain because I'm not fast at math, right?
So wrapping up this conversation, that was a perfect segue. What gives you hope in the math education space right now? That was good.
Podcast now, and I knew it was coming. So I've been ruminating on what am I going to say, and I want to make sure I didn't repeat what someone else said.
Oh, that's so funny. It's okay to have the same answer as somebody else. You're not cheating.
So first, what gives me hope is when I'm, out in schools and I'm witnessing the kids, and they do things. Every single time I'm in a classroom of kids, some kid surprises me with something in a way that I never would have thought of, that I never would have thought a student at that grade might think about. And to have the reaction of the teacher of like,
Yeah.
I didn't know he thought like that, right? Like it's, or she, right? So the power of that. So the students give me hope. The teachers that I work with, they are just, oh God, they're doing so much right now with so much stress on their shoulders. And, so I love hearing people, the voices in the field, people who are in the classrooms and what their experiences are. Timmy McMorrow, I adore her, and she loves building thinking classrooms. I met her at the first Building Thinking Classrooms conference, and she's just adorable human, amazing human. But she's doing Building Thinking Classrooms in her first and sometimes combination grade 1 and 2 years of teaching kids. Like she's doing this work with grade 1 and 2 kids. Right. So it's doable. So when I hear from teachers saying, oh, this can't work in my classroom, it's like, it's being done. Right. And so she has all the time teachers on her podcast who are doing this hard work, and the beauty, she calls it the magic and messiness. Right. It's not like you do BTC and everyone's sitting at the boards and suddenly math education is fixed. Like it is hard work. It is magic.
Yes.
I've witnessed the magical moments, but I've also witnessed the messiness. Right.
Me too.
But that's part of learning and growing. That's part of what our experience of learning and growing is. So that gives me hope to know that there are so many people out there doing the best thing for kids. Your podcast, honestly, I listen to a lot of math podcasts. It's all I listen to. But that gives me hope too, right? Listening to interviews of people who are doing their part to change the world for the better, to provide access for each and every student to believe in themselves, and changing the teachers, and then knowing the impact of those teachers on their future students. Like I taught some pre-service mathematics classes, and I taught them and trained them how to give math running records. And we had students come into the classroom one night. They're different teachers in my district who had kids would bring them in as our guinea pigs. But my student teachers got to give math running records to kids, and then we had games and activities that they would go home with, catered to where they were on their journey. Beautiful. And helping the teachers understand that, right? So to know the scale of impact goes beyond just who I even have in front of me, but that it goes on in the teachers that go on to become teachers, right? And then they're sharing it with their collaborative teacher, and they're like, well, what's this about, right? But I know the key to that math running record is we're listening to the thinking of the kids. And that's the critical piece. And that we can help know that fluency journey is not about being fast and accurate and memorizing facts. It's about number relationships based on the properties, based on the meaning of the operation that extend to all set of numbers, right? It's a connected math journey, and we have that power to help the student, and it's long lasting, right? It's going to affect the life. So many people who have had negative experiences choose not to have a math class in high school, choose not to do math in college. They're locking themselves out of careers that incorporate math because they somehow think they're not a math person, which is not true, right? So the power that we have is that gives me hope that there are so many people on this journey that are doing the same stuff that I'm doing. We're doing it in our own corners of our world, wherever we meet. But I just get thrilled to meet other people like you. That I just feel like we're math soul sisters. You get
100%,
right?
100%,
hours and hours, and it can be lonely and isolating as a self-employed consultant. I'm on my own. I'm not with a staff of teachers anymore, but I felt in the math ed community particularly, there's so many brilliant and kind and generous educators. I feel connected to that community, and I've been very blessed in my life to have my closest friends now are from the math ed community, right?
Isn't that
I
great?
love all my friends in my life, but like they're getting what I'm doing. We're all on the same journey, and that gives me hope for sure.
Thank you so much for this conversation. It was a pleasure to have you, Ann Elise, and I hope that I'm sure I'll get to meet you very soon in person at one of these conferences that's coming up. But I thank you for your commitment to education and everything. But where can people find you? Where can people find you? Where can they connect?
Yeah, so I have a website. So my name, anneliserecord.com. I also am on social media a bit. I mean, it used to be a thriving community, but I understand why people have left social media in droves. But I do facilitate some Facebook groups like Math Running Records. We have about 18,000 people in that group now. And Dr. Nicki and I provide advice and resources and things. And also one called Math Intervention Matters I'm facilitating now. There's 25,000 people in that group. So it just means there are people around the world willing to talk and give advice and share ideas and share free resources. We all learn better together. So those are kind of places you can find me. I'm on Instagram as well. So I'm not on X anymore, but I am on Blue Sky.
Great.
And so those kind of places. And conferences. I love going to conferences. I'll be at the Indiana conference this June, the Keep Indiana Learning. I'll be presenting there. I'm also going to be at the Get Your Workshop On. Are you going to go?
Me too. I'm there. I'm presenting. Yes, I'm presenting as well.
Also, I heard the podcast with Allison Mello.
Yeah,
and
I've got my jacket ready to go.
They put on the most amazing, fun,
I can't wait.
Powerful conference. I went to it last year. It was fantastic. And so thrilled again to present and be there. So very much looking forward to that. I now live in Wisconsin. So I was living in New Hampshire, but our children 10 and 6 years ago, our son and then our daughter moved to Wisconsin. And so I'm now in the Wisconsin, the Midwest. So the Indiana conference, like I want to go to conferences nearby, where I'm living now. I just moved here 3 weeks ago and bought our home here because we love our children very much, but our first granddaughter is around.
Well, that's
she's 2 months old, Callie,
golden.
And so, to have her 20 minutes away from me, I can just go and hold her whenever I want. I go for a walk with my daughter and hang out with our son and their spouses. It's just, it's fantastic. So I'm thrilled to go back to New England, to Foxborough, to go to Gillette Stadium and present there and see everyone at the Get Your Workshop On. And then I'm also, I'm presenting at a Math Intervention Summit. So Juliana Tapper is putting on a Math Intervention Summit, which is free for educators. And I can give you a link to that as well to put in the show notes. But
amazing.
But I think that the interventionists, we need to understand the research behind what's most powerful in intervention. And too often I'm finding the interventionist doing something very different than what's happening in the tier 1 instruction. And that's not best practice. I love the TNTP article, the research that they did on the schools that successfully helped children achieve more than a year's growth in a year's time. And they had 3 things that were in common of all those schools. There was belonging. Mm-hmm. So every student knows they can learn math and every stakeholder has the same understanding. The consistency. Are we naming strategies like double and halving consistently between all the grade levels? So we have that between classrooms and between grade levels, between districts, schools in a district. And lastly is coherence, which is the interventionist. Like, are we working in intervention on what's happening to help the student be successful now in the classroom? Yeah. So it's coherent for them. Is the diagnostic computer program that don't get me started. But we're not
going to go there right now.
Yeah, but it needs to be working on a connected thing of what they're working on tier 1 right now, and then also the tutors that a student might have. So is it all coherent? So those 3 aspects are such a critical piece. So I think interventionists, we need to make sure that they're also knowing what is our time is can't be wasted. Time is limited. How can we be most powerful? How it makes all our students be able to learn.
Well, Ann Elise, thank you so much for being here today. I really appreciate this conversation. I appreciate you for all your work. And
I'm so honored to be here. I'm so happy to connect with you, Pam.
So great. Thank you so much, and enjoy that grandbaby.
Thank you. I sure will.
I'm Pam Brett. Thank you so much for joining me on this episode of Blue Glasses Math. Please follow me wherever you get your podcasts and follow along on the conversation on Instagram. And remember, being a math person is all just a matter of perspective.